Hello everyone. Today we're going to talk about different types of reactions. We are going to talk about 6 specific categories of chemical reactions. A few of these categories can overlap with each other. In other words, if you look at a chemical reaction, you might be able to label it in multiple different ways. This does not cover all of the possible reactions that can occur. This just covers a majority of inorganic reactions and the ones that we will be seeing in class. Our first category is synthesis reactions. This is a chemical reaction in which 2 or more reactants combine to form a single product. The way to remember this is that the word synthesize means to create. The general idea is you are creating a single product from usually its constituent elements, although occasionally it might be from other compounds. This has a very general form of something, let's call it A, plus something else, let's call it B, yields a product, let's call it C. An example of a synthesis reaction would be the synthesis of ammonia, where 1 nitrogen gas and 3 hydrogen gas yields 2 ammonia gas. You'll notice there are 2 or more reactants and there is 1 product. The opposite of a synthesis reaction is a decomposition reaction. A decomposition reaction is a reaction in which a single reactant breaks down into 2 or more products. A way to remind this is that the word decompose means to break down. Think, mushrooms are decomposers. They help to break things down. This is generally considered to be the opposite of synthesis because while synthesis is creation, decomposition is to break something down. So you'll notice the general formula for it looks kind of like a reverse. The general formula for this would be that something, let's call it A, breaks down to form at least 2 other things. Let's call them B and C. An example of a decomposition reaction would be the decomposition of hydrogen peroxide, shown here, where 2 hydrogen peroxide molecules will decompose to form 2 water molecules and 1 oxygen gas. Our third type of reaction is the single replacement reaction. In this reaction, a reactive element will take the place of another within a compound, essentially kicking out that second element. In general, what is going to happen is either a metal will displace a metal or take its place, or a nonmetal is kicking out a fellow nonmetal. The general form for this would be that some compound, let's call it AB, and a reactive element, let's call it C, yields a new compound where the element C is now part of the compound to make CB, and the other element A has now been kicked out. Note that this form was specifically written with metals in mind, since the C and A that are switching places are in the front, where the cations or metals are traditionally written. An example of this reaction would be the displacement of silver by lithium, where 1 lithium and 1 silver nitrate yields 1 lithium nitrate and 1 silver. For these particular reactions to occur, you must have evidence that they occur. In particular, what will happen often is a color change. Metals usually have slightly different colors, or possibly they might also produce a hydrogen as part of a secondary reaction following the initial displacement. The list of which chemicals are more reactive than others is found on what we call an activity series. If a metal is higher on the activity series, this means it is very reactive. That means it can displace a metal that is lower on the series. We will learn more about these in a future lab. Our fourth category of reaction is double replacement reactions. For a double replacement reaction, 2 aqueous ionic cations are going to swap their anion partners. This is generally specifically only takes place in aqueous solutions. It has a general form of 2 compounds, let's call them AB and CD, will switch their partners. So now, on the product side, we have CB and AD. Notice how the metals have switched places. An example of this might be silver nitrate and lithium chloride yield silver chloride and lithium nitrate. Like the single replacement reactions, we need evidence that a reaction has occurred. For this is either through the formation of water for acid-base, a special kind of this kind of reaction, or through the formation of a solid precipitate. So, in order to predict whether or not a precipitate will occur, you need to know solubility rules. We will learn more about this in a future lab. Our fifth type of reaction is a reduction-oxidation reaction, or more simply called a redox reaction. In this kind of reaction, electrons are being exchanged as part of the reaction. This means that the formal charge, the charge that is assigned to a particular element, will change. This has 2 halves. One thing is reduced and another thing is oxidized. Reduction is occurs when electrons are gained. The charge of a particular species will either become less positive or become more negative as the electrons are gained. Oxidation is the opposite. Oxidation is the loss of electrons. And so the formal charge for that particular chemical species will either become more positive or less negative. A mnemonic device to help remember which is oil rig. Oxidation is loss and reduction is gain. An example of a redox reaction might be the displacement of silver by lithium that we saw for a single replacement reaction. Redox reactions are commonly a secondary way that you can label a particular reaction. Our sixth and final type of reaction that we are going to discuss is a combustion reaction. Specifically, we are going to focus on the combustion of a hydrocarbon. But more broadly, a combustion reaction is a reaction where a reactant burns in the presence of oxygen gas, which has the chemical formula of O2. Oxygen is diatomic, that is, there are two atoms bound together in its elemental state. Specifically, we're going to focus on hydrocarbons, which would be chemicals where you have a carbon, some number of them, and some hydrogens, some number of them. You may also occasionally find a nitrogen or a sulfur or an oxygen in here, but generally what you just need is the carbon and the hydrogen. Therefore, the general form of this particular reaction will be that the hydrocarbon and oxygen gas react to form carbon dioxide and water vapor. An example of this, an unbalanced equation of this, would be that propane and oxygen gas react to form carbon dioxide and water. You'll notice for the combustion of a hydrocarbon, the products are always the same. It is always carbon dioxide and water vapor. That's it for now. There are other types of reactions out there, but we won't be covering them in this class. Good luck, everyone.